Okay, today we're going to work on a problem on a differential, on a first order ordinary differential equation problem that will be solved using an integrating factor. Now, in order to proceed with this method, we need to find an equation that is in this form, or at least put it in this form, and once we do that, we will have full license to use the method that I'm about to show you. Okay, so how does that method work? Well, the first thing that you want to do is multiply both sides by this particular function m, which is e to this particular guy over here. So multiplying everything there in the red box, both left and right hand sides, by m gives us the following. So I get e to this guy, which is our new friend, times y prime plus the same guy times p times y is equal to new guy times q. Alright, and why in the world, you may rightly ask, have I made an already difficult situation more cumbersome by multiplying things through by m? Well, let me just push things around here to make more space. If you carefully look at the left-hand side, what you actually have is something that could come under a common derivative. And it is nothing other than the derivative of the new guy we introduced times y, and we will leave the right-hand side unchanged. Okay, so notice here that we have a situation that is potentially easier to deal with than what we started with. And this is what I mean. If we integrate both sides now with respect to x, we get the following situation. On the left-hand side, we have our very familiar friend, and on the right-hand side, we have plus a constant, which came from the left-hand side. And now, because it's getting to be a little tedious writing this out, and the exponential, I'm just going to call that I, and then let me just make some more space here. Now I could express y in the following way. Y is nothing other than e to the minus capital I times e to the capital I times q. Sorry, there's an integral here, plus c. So this is the promised solution. If you can start out with the standard form that we mentioned before, if you can begin with this right here, if you can put your equation in this standard form in the red box here, then you have license to seems like I lost my solution here. Sorry about that. Let me just move things around again. So you can move straight to the solution, which is written here. And now what we're going to do is we are actually going to solve a problem using this method that was introduced. Okay, so here is my problem in blue. And the question is this guy actually in standard form? And remember, standard form basically said the following. So I need to bring my problem to look like that. And if you actually look, I have a y prime here and I have a y prime here. I have a y here and a y here. And multiplying the y is a function of x. And if you look at this thing here, it actually is nothing other than a function of x. And then on the right-hand side, I'm supposed to have another function of x, which is what I have here, corresponding to q. So I'm on good grounds here, and I could legitimately use the solution method that I discussed earlier. Okay, the next thing we want to do then is we want to find what I is. And as you can check for yourself, I is this thing that I'm writing right now, 6x over 1 plus x squared dx. Now remember that I is nothing other than the integral with respect to x of p, which in our problem is over here. So I haven't done anything strange here, in other words. And this gives us 3 times the natural log of 1 plus x squared. Okay? So I'm going to take these guys, so I'm just going to shuffle things around a little bit more so that I have space to work. Okay, so now that's I, and so e to the capital I is equal to e to 3 natural log 1 plus x squared, and that is very nice and conveniently reduced to this particular form here, or simplified. Alright? And so then, y times e to the capital I is equal to the integral of 2x over 1 plus x squared times 1 plus x squared cubed dx. And now we just need to do a bit more by way of simplification and cleaning things up. Alright, and that gives me this thing over here, 1 plus x squared squared dx. As you see, there's a cancellation that takes place here. I'm taking that to 2. And then that itself gives 1/3 times 1 plus x squared cubed plus an integration constant. And just permit me to make a little more room. We're almost home now. And this finally gives us, this is y by the way, 1/3 plus the constant we just mentioned over 1 plus x squared cubed. And that, you must admit, is pretty cool.